Okay, so lesson 7, we're going to be talking about the law of conservation of momentum. I think from the wordings, you can already tell what we're going to be working on. We're going to be working with momentum. And momentum, if you recall, is mass times the velocity. And they're telling you that they are conserved. So basically, in a collision, if I tell you that if I have an object that is traveling this way, if I have a car that is going towards the right, and if I tell you that there is another car that is going upward to the I should say east and north, if they got into a collision and I asked you, what do you think will happen if they got stuck together? Which way do you think they're going to move? Okay? So car A going to the east, car B going to the north, and they got stuck together and they keep moving. What do you think the kind of the final path that it's going to do? Okay, what happened is, I don't know if you get this, but basically car A and B, if they're stuck together, they should be traveling towards the east-north direction. Okay, the reason for that is we have initial momentum. This is the initial momentum. And this is the final momentum, and they have to add up to be the same. So when we're dealing with momentum, we actually use P equals P prime. Okay, P represent the initial, before the collision, what the momentum is. And then P prime, we use a little dash thingy, we call it prime. This is the final momentum, and they're telling you that it has to be the same. So when two or more objects collide, the collision does not change the total momentum. Okay? Whether momentum is lost by one object, gained by the other, the total momentum of the system is conserved, and it's the same. Okay, another typical of things, I don't know if you have ever experienced it, but if not that I've ever used a gun before, but if I'm telling you that if I have a gun and I'm holding onto it, this is my hand. If you fire a bullet forward, have you ever heard of this thing called the recoil? Like kind of like the backward forces? Like your hand will actually feel another forces that is going to the back. And the reason for that is, if I have P equals P prime, the initial momentum is 0. If I call this P1 prime and P2 prime, they're going to opposite directions. These two have to add to 0. So that's why if I have a bullet that is going forward, the momentum will cause a force that's going backwards to my hand, so that we're still conserving the momentum. And here's the mathematical proof how come we're saying that the momentums are conserved. Okay, so we started with the third law. So the force on object 1 to 2, it's the same thing as the negative of the force of object 2 acting on 1. So this is based on the action-reaction force. So I know that F equals to ma, so we subbed it into the equation. And since acceleration is change in velocity over time, so they replaced it with the a, and that's where the third equation come from. And because this is a momentum talking about the same object, we can assume that the time is the same. And if the time is the same, then we can cancel the time. So we're left with m delta v, which is the change in momentum, and they are the same. Expanding it further, be a little bit careful that the v prime represent the final velocity. So I know there are all these 1s and 2, so be mindful. So this is talking about object 1, and this is talking about object 2. And the change in the final speed minus the initial speed. So they have proved that. So they've expanded out, collect the like terms and all those stuff. And they found out that this is now the initial, when I first start off object 1 and 2, what their speed are. That tells me the total momentum at the beginning. And then it equals to the final momentum. So another way to write this is P equals to P prime. It is still a vector. So what that means is if you have a velocity that is heading opposite direction, you would have to put 1 as negative. And we're going to do examples like that. So we've drawn a conclusion that if I have total momentum of any system of a 2 object, they are conserved. And also the system must be isolated, so we don't have extra forces that are acting on it from the outside when this is happening. Okay, and the law of conservation of momentum is very useful when we're solving issues like collisions, when I have a car smashing onto another one, or things like an explosion. We're going to be talking about two-dimensional later on. Okay, so example number 1. I have a 10,000 kilogram car traveling at a speed of 25 to the right, and it strikes the identical car at rest. If the car locks together, when they're locked together, is it okay if I tell you that their final speed is the same? So V1 prime should equal to V2 prime, right? Their final speed are the same when they're locked together. What are their common speeds? So they wanted to find out what is this final speed. With questions like these, it's a good idea to do a chart for yourself with the 2 different mass, so m1 and m2. What is the initial velocity? So beginning, so I'm going to write initial here, and final. And you need to get used to the wordings. V1 and V2 is actually the initial speed for object 1 and object 2. V1 prime and V2 prime is the final velocity for object 1 and object 2. And in this case, they told you the masses are the same, so I'm going to actually write in the masses here. So I know that M1 and M2 is actually the same thing. They're both, because they're identical, they're both 1 times 10 to the 4 kilogram. The initial speed for object 1 is 24 meters per second to the right on a stationary cart that is identical in mass. I don't know what the final speed is, but that's actually common. I'm actually call them both V prime because they're exactly the same. I'm just giving it the same name. You can call it V1 prime if you want. Due to the law of conservation of momentum, yes, you have to write them all out initially. Okay? So kind of like working out total momentum, we have 2 objects, object 1 and object 2, right? And each of them have a momentum. So you're going to have V1, M1 V1 and M2 V2. And that's the beginning. And then we're going to do the same thing when it's the final. I still have object 1 and 2. I have M1 and M2, but this time it's going to be V1 prime and V2 prime. And that's how you do your total momentum. And so we're going to plug them all into the equation. So M1 V1 adding M2 V2, initial momentum for object 1 and 2. And then M1 and M2, but this time their final speed. You have to start off with it, just like the conservation of energy requirement. You have to start off with the conservation of momentum. That's a concept. You can't just go about and drop all the zeros. You have to start off with, since I know the law of conservation of momentum, and this is where they goes. So you have to write this first equation before you cancel them out. Okay, now I can cancel. I know that V2 is 0, so that means this term is gone. And the other thing you're allowed to do here is, since the masses are the same and they're in every single term, you actually can cancel all the masses. If the mass are not the same, you cannot cancel, okay? And if they're not in every single term, you cannot cancel. But because they're the same, I can cancel. And then the other thing I could do is I'm going to plug in my V1 prime and V2 prime for the same value. So let's see what I have left. So on the left hand side, I only have V1 left. And on the right hand side, I have V prime adding V prime. So I'm just adding them in because they're telling you that they're the exact same speed at the end because they got locked together. So because the speed is the same, so I know 2V prime is equals to V1, which is a 24. So V prime, final speed for the two object is going to be 12 meters per second, and the direction is right. Read this question carefully. Pause the video if you want. Draw a chart. Calculate the recoil velocity of a 5 kilogram rifle, so the gun part, that is shooting a 0.050 kilogram bullet at a speed of 120 meters per second. Okay, so two object. I'm going to set up my chart for initial and final. I'm going to write these guys out. And M1, M2. So M1 is my rifle. My rifle is 5 kilogram. And M2 is my bullet. It's 0.050 kilogram. Press the pause button. Where does the 120 goes? And it looks like I'm missing a whole lot of stuff. What's happening? Where are you going to put your 120 meters per second? Okay, hopefully you're picking the bullet, right? So obviously this is the bullet, but is it V2 or V2 prime? Which one? It's your V2 prime, your final speed. Then what would your initial speed be for the bullet? Is it okay that I'm looking for this? I'm looking for the recoil velocity for the gun, for the 5 kilogram. All right, so I don't know if you recall, right? Momentum could start from 0. So basically, before it got fired, my total momentum is 0 because none of the bullet or none of the gun moving. So my initial speed is actually 0 for both of them. And then the gun gets fired. Your bullet got pushed out to one side. It didn't say direction, so I'm just going to say this is forward. And then we'll figure out which way it will go. We already talked about it. The backward force acting on the gun should be opposite. And we're going to do the math part to prove this. Okay? So this is the tricky part. Knowing that the initial speed is 0 for both the bullet and the gun. Starting it out, P equals P prime. And P initial momentum is M1 V1, adding M2 V2. Final momentum is M1 V1 prime, adding M2 V2 prime. I know a lot of M&Ms, a lot of M&Ms. I know there's a lot of M&Ms. And yeah. All right, you fill them in. Hopefully you get used to them, okay? All right, so let's start plugging in numbers that I know, things that I can cancel. All right, let's take a look. I have V1 is 0, V2 is 0, and then the other ones I don't know. So I have 0 on one side equals to M1, V1 prime is my unknown, adding M2, V2 prime. Okay, so that means I'm going to end up with a negative value. But does it make sense that it should be negative? 0.05 times 120 is 6. So divide both sides by negative 5. I'm going to end up with negative 1.2 meters per second. To forward, meaning the gun is moving to the